Today we're going to start with a little game where you are going to put out a number line. So go off near the bottom of your paper and put out a number line. And if I roll 2 dice, do you get that the smallest thing I could get is a 2? I could also get a 3. 4, 5, 6, 7, 8, 9, 10, 11. 12 is the biggest thing I could get because you roll 2 6s, you get a 12. Label it like that. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, now I'm going to give you imaginary pennies that you would put on this. And I'm going to give you 10 imaginary pennies. What I would do for that if I were you is you got your little lasso thing, right? So I'd make like a little circle like a penny, okay? And then I would grab it and copy it. Now mine looks different probably than yours does, but this is my copy thing, and it makes a copy of it. Now I just copied kind of the wrong thing, so I'm going to try that again. And my copier, there's another penny. And then I can grab it and move it. And I'm going to place, and I'll put my 10 pennies out. I'm going to copy it again. I think you guys have a way to do this like over and over again. I don't. I have to keep on using my copy tool. And put out 10 pennies wherever you think is most likely to come up. And maybe you think it'd be smarter to like be strategic like this and like move it around. Maybe some of you think that you're going to have like a lucky number, like 11's going to be my lucky number. And I'm going to put a whole bunch on that. So put a total of 10 pennies out. If you just want to make them by making dots like this, I'm fine with that. You don't have to make it complicated. 1, 2, 3, 4, 5, 6, 7, 8, 9, and I have 1 left, and I'm going to put it there. And wait a minute, this one needs to go somewhere. I'm going to put it there. So basically, I just spread them all over the place. The goal of this game, now that you know this, you might want to change where you put your pennies, is to get rid of all 10 pennies before everybody else does. So basically, you got to try to predict which ones I'm going to roll when I roll 2 dice. In a moment, I'm going to walk past and see where you placed your 10. I was betting on 11s. All right? So I'm going to pause for a second and see where you've placed your 10 pennies. So nobody knows which of these is going to be the best spot, but it's a great chance to talk about probability and how much you know about it. I can tell some of you know more than others. All right. Now, do you think my setup was the best setup? It is not. And you might be like, well, how do you know? I mean, maybe 11 does come up a lot. This was not a smart way to do it. Okay, the way I did it. So don't change yours now. Okay, leave yours, just leave your 10 pennies where they are, because once I start rolling, then it'll become obvious that it's not fair for you to move them during the game. All right, so I'm just going to keep track now, and we'll talk afterwards about what would have been the smartest place to put them. All right, so I'm rolling, and the first number I got was a 4. If you had a penny there, you can remove it. Now I'm putting them in, you take them out. Okay, so if you had a 4, you get to take it out. Did anybody have a 4? Oh, a lot of you got to take a penny off, yay. And your goal is to try to get all 10 pennies off. All right, I just rolled a 6. So then you get to take a penny off. Not all your pennies, just 1 penny of the 6s. Now, if you put 2 pennies on 6s, you can take 1 of your 2 off. You get to take 1 penny off of a 6. Yes? Does that answer your question?
Yeah.
Okay. Next one, 7. 7, lucky 7. Did anybody put more than 1 7 down? That was smart. Some of you understand probability more than others. All right, so far, those are my numbers I've rolled. There's a 9. Did you notice I'm not rolling those n numbers like 2 and 3 and 10 and 11 and 12? Are they all equally likely to come up? No, they are not. 7, lucky 7. If any of you had two on there, you could take off the next one. You only take off 1 at a time, right? Next one, 6. All the numbers are coming up in the middle. What the heck? This is a ripoff. 11. Ooh, I did have an 11. 9. Is probability coming out exactly the way you would expect it to? No, because life is not fair. I wouldn't have expected an 11. I would have expected an 8 by now, because if you understand probabilities, they come out more in the middle when you have two dice like this. I'll explain why in a minute. So far I have 2, 4, 6, 7, 8. Here's my 9th one. It's another 4. That is not what I would have expected. I would have expected a 5 or an 8 or a 10, but... And here's a 10. If you had a 10, now you get to take it off. All right. Here's another 9, and I bet by now that's not helping anybody. Did anybody have 3 9s like from the beginning, and now you get to take them all off? Okay. See, nobody even bet on that. All right, next up. The way we do this in the Catan Club is if one of the 2 dice goes in there, we roll both of them, and it's an 8. Finally, I bet a lot of people got to take an 8 off. How many of you are down to like 4 or less chips? Ooh, a lot of people. Anybody down to 2 chips? Anybody down to only 1 chip? Okay, where were my 2 people again? Are they guaranteed to win because they're ahead? No, we don't know. All right. Next one is a 5. Ooh, I bet that helped some of you. Is anybody down to only 1 chip left? Ah, and I noticed you placed yours really strategically, that better than a lot of people, and look at that, you're winning right now, but that doesn't mean you're going to for sure win. If I had to guess, I bet your last one's on an 8. Aha. Well, it's a 10. And it's a 12. There was only a 1 in 36 chance of that happening, but it happened. All right, next one, a 5. Has anybody won yet? You just won? Okay. Another 10. Probably didn't help anybody. Oh, it did help somebody.
No, I have 1 more left.
Oh, he's got 1 more left. Okay. All right. 6. Now, the way this is supposed to come out, it's kind of doing it in that the middle numbers are rolling more, like there isn't any 2s, there isn't any 3s, there isn't any 11s, or there's only 1 11, there's only 1 12. But it's not doing one thing right. 8s. 8s should have come up more. It's only come up once. This is crazy. Does that mean it's more likely I'll get an 8 right now? No. No. On one roll, that does not mean like the forces of fate are going to come down and make the 8 happen. Could it happen? Yeah. Is it likely to happen? Actually, yes, but it's not more likely to happen. It's a 7. Anybody win yet? All right, and you must be getting close. How many of you are down to 1? Now we're up to like 7 people that are down to 1 left. And it's another 10, and I doubt that helped anybody. Probably nobody put 4 on a 10. And it's a 4. And there's a 5. Did that help anybody? Okay. It's another 5. What is that one number that's just not rolling? An 8. I just need an 8. Oh, it's just another 7. It's another 4. It's a 9. Do you get probability can be like frustrating? Because it's that 8 should have come up a ton of times. It only came up once. And that's the real world for you. 9 again. I would have never predicted that. You get way more 9s than 8s. It doesn't make sense. 7, lucky 7. Now, I am getting a lot of 7s, and that actually makes sense. 11. Shouldn't have gotten 2 11s, only 1 8. That's crazy. Another 12. Crazy. Another 7. It just will not roll. An 8. Come on. It's a 4. Oh, somebody won?
Yeah.
All right, we had our first winner. Was that fair? Well, it was fair, but was it like what you would expect? No. That should have come up like 5 more times than it did, but that's how life goes. All right, so here, let me show you, and congratulations, by the way, nice work. This is how it's supposed to come up. I'm going to chop off a few of those, and I'm going to move them around. There should have been another few here, like this. 6, 7, and 8 are the most rolled ones. And there shouldn't have been so many of those. There should have probably been like one of those. Have you ever heard of the bell curve? Kind of looks like the Taco Bell logo. It's low on the outsides and it's high in the middle. That's a probability thing. And let me explain why. So if I roll a 7, do you get that I'd need a 4 and a 3 to get a 7? Or a 5 and a 2 to get a 7? Or a 6 and a 1 would give me 7? Or all of those backwards. I know it seems like that's the same thing. A 1 and a 6 and a 6 and a 1 are the same thing, but I have different colored dice. Okay, this is like the red die here, and this is like the white die here. So then it could all be reversed. The red die could get a 2, and the white could get a 5, and last but not least is this could get a 3, and this could get a 4. That's why 7 should come up the most, because all of these things make a 7. There is 6 out of 36 possible things that can happen, and that is about as hard as probability gets. There's a 6 in 36 chance of getting a 7. What's the only way to get a 12? A 6 and a 6. And you can't reverse it because they already both have 6s. So there's only 1 out of 36 ways to get a 12. And there's only 1 out of 36 ways to get a 2, because it's a 1 and a 1. So these are the least likely, and the most likely is the 7, and then the 6 is also pretty likely because there's a lot of ways to get a 6. All right, so moral of the story. Am I trying to like teach you to gamble better? No, that's not it. Although this does help, because when people are in Las Vegas, a lot of people would seriously think that a probability of a 7 and a probability of a 9 would be like the same. They aren't at all the same. I showed you, here's the 6 ways to get a 7. There's far fewer ways to get a 9. You can get a 6 and a 3. You can get a 5 and a 4. And that's it. And those reversed. So 4, 5, and 3, 6. But that's only 4 ways. There's 6 ways to get a 7. So that's 4 out of 36 compared to 6 out of 36. And this was way more likely. Especially if you make it more extreme and say a 10 and a 7. A lot of people think that those would be equally likely. They're not even close. Okay, because a 10, you got to get a 5 and a 5. Or a 6 and a 4, or a 4 and a 6. There's only 3 ways to get a 10. There's 6 ways to get a 7. A 7 is twice as likely as a 10. So if we were to play this game one more time, you would arrange your pennies this way, with lots of them in the middle, not many on the ends. That's the best way to do it. But sometimes life is cruel. We should have gotten like 4 of the 8s, and we only got 1. So. Okay, you learned a little something about probability there. So let's go to like a more normal-ish kind of thing. Here are the words I'm going to use a lot. An event, that's just something happening. Like I roll a die, I pull a card out of a deck, I flip a coin. That's called an event. An outcome is what came out. You know, like I got a 6. Or I flipped a heads on a coin. The sample space, that is a list of all the outcomes. So I did that for my thing I just did a second ago. I listed all the things that could come out. That's the sample space, is all the things that come out. If I flip a coin, you might think the answer is if I flip a coin, I can either get a heads or a tails. Then the sample space is that. It's a list of all the things that could happen, heads and tails. It's just a list of the things that can happen. That's the sample space. The probability is the chance that it'll happen, and it's between 0 and 1, and number of ways it can happen, and the total number of outcomes. The way I want you to say that is it's the outcomes you want over possible. I want to give you a one-word thing to remember. Probability is what you want out of what's possible. Do you get, when there's a die, there's 6 things that are possible. And if you only get to pick one thing, then there's one thing that you could guess, and there's 6 things that could happen. Therefore, there's a 1 in 6 probability. It's what you want. You only get one thing. Like, pick, Eli. Give me a number. You were lucky today. Not quite lucky enough, but pick a number.
I'll do 9.
Okay, so I'm going to roll these 2 dice and see if we get a 9. Oh, we got a 7. Well, what did you want? How many different ways were there to get a 9? Well, I could have got a 6 and a 3 and a 6, a 4 and a 5, and a 5 and a 4. So there were 4 ways to get a 9. 4 out of 36 chance it would happen. But if there's a 4 in 36 chance that it would happen, do you get there's a 32 in 36 chance that it won't happen? All right. So it's what you want over what's possible. Now just pick a number from 1 to 6.
4.
It's a 4. What was the probability of that? What was the probability she was going to guess right? Well, how many things would have won for her? 1 thing. Out of how many things were there on a die? So it was a 1 in 6 probability. And by the way, if you want to, you can get decimals for these answers, but do you get that's extra work? You got to go type it in. 1 divided by 6, you get a decimal. But I'm fine with you leaving answers like that. So it's what you want over what was possible. All right. Today is short, but it's not that short. Let's clarify when we are out of here. We're out of here at 26, so we still have about 20 minutes left. So that must be the... Oh, I know. It's because of weird lunches. So for us, we're out of here in about 20 minutes-ish. All right. So with a coin, you have a 1 in 2 chance of guessing right, because there's 1 thing you want and 2 things possible. With a die, a dice is 2 dice. A die is the word for 1 die. One of the 2 dice is a die. You'd have a 1 in 6 chance. There's 1 number that you want to come up and 6 possible. Okay, what if you have 2 dice though? If you ever have 2 things, you multiply them. I'm going to just say that again. If you ever have 2 probabilities, you should multiply them. So if I have a 1 in 6 chance of getting the number I want on this die, and a 1 in 6 chance of getting the number I want on that die, there's only a 1 in 36 chance of the exact 2 dice coming up the way I want. On the red die, I want a 5. On the white die, I want a 1. If I say it that way, then there's on the red die a 5, there's only a 1 in 6 chance of that. On the white die a 1, there's only 1 in 6 chance of that. Then there's only a 1 in 36 chance that I will get a red die with a 5 and a white die with a 1. So if you have 2 things, you multiply choices. Remember how I said to write down want over possible? Multiply choices. And there's a fancy name for this. It's called the fundamental counting principle of probability. But I'm going to give you a really easy way to do it. Think for a second, how many shirts do you have? I probably have like 30, maybe 20. I'm older than you though, so I've been collecting shirts for a long time. Some of my shirts are older than you are. I got some old shirts. So anyway, let's say I have 20 shirts. If I have 20 shirts, and I also have probably 10 pairs of pants that actually fit me, then what's the probability? Well, first of all, we got to know how many different outfits could I have? Is it just 10 plus 20 is 30 outfits? No. I said to multiply your choices. I have 10 choices for shirts, and I have 10 choices for pants. Then my outfits, I have 200. 20 times 10 is 200 different outfits I could wear. That means like this shirt with a different pair of pants would be a different outfit. Okay, so you just multiply your choices. That's why McDonald's can say you have over 1 million meals at McDonald's. Might be like, there's not 1 million meals. They say that if you change your pop from cherry Coke to orange, that it was a different meal because it was slightly different. If you count slightly different, there are way over 1 million meals you can get at McDonald's because you multiply all the choices. They might have 6 different types of drinks. They might have 10 different types of entrees. They might have three different things you can put on your entrees, like ketchup, mustard. If all those things make it different, then you multiply all your choices together. Chipotle is famous for this. You go to Chipotle and you get how many different kinds of meats? Probably like 5 different kinds of meats you can pick from. And then 2 different kinds of rice. And then 2 different kinds of beans. And then whether you got, I guess I could call this 2 choices of peppers. You either get the peppers or you don't. Because they have like the fajita thing. It's like a mix of onions and peppers. You either take that or you don't. You have 4 different kinds of salsa. You see what I'm doing here? I'm just multiplying them all. Then there's many different outcomes possible. So multiply your choices. Try to remember that. Probabilities are all complicated except for this one kind. Just multiply them. So 5 times 2 is 10, times 2 is 20, times 2 is 40, times 4 is 160 choices. If I was accurate about Chipotle, there'd be 160 kinds of ways you could make your burrito. Oh, and then there's burrito in a bowl versus burrito inside an actual shell. So then that's another choice. So then that probably brings it up to 320 because you times your choices. All right, so multiplying choices was a key thing. Go on to this page. What's the probability you get a 4 on a die like this? 1 in 6. What's the probability you get an odd number? Well, then there's 1 or 3 or 5 out of 6. And I want you to write this little tip down. Oh, these are so good, I'm telling you. I've done probability for a long time. Or means add. You multiply your choices, but or means add. So I'm going to write this down. Or add. Multiply choices. And probability is what you want over what's possible. If you can remember all of these things, it'll help you at key moments, like right now. 1 or 3 or 5. What did I say or meant? Add it. 1 and another one and another one. That's 3 out of 6 of them will be odd. Doesn't that make sense? 3 out of 6 would be odd, and then 3 out of 6 would be even. So it's 3 out of 6. And or was a hint that you should add those 3 things together. 1 plus 1 plus 1. It's not 5 plus 3 plus 6. Otherwise, your probability is 6 out of 6, and you know it's not 6 out of 6 chance. But that wouldn't make any sense. You're just saying there's 3 things that are odd. See? Add them up. 3 out of 6. All right, how about a 2 or a 5? Ooh, I said or means add. So you have this and this. You have 2 things. And it can't be 7 out of 6. That doesn't make any sense. Probability is 7 out of 6. There's no such thing. The highest probability is a 1, so it can't add them that way. Oh, yeah. It's just 1 for this and 1 for that. There are 2 out of 6 things. You would win 2 out of 6 times if you win on a 2 and a 5. Or means add. Okay. Now I got the spinner. It's a classic. What's the most likely to happen? Blue, red, yellow. What do you say? Blue. And I couldn't see green for a second there. That yellow and that green like look the same to me, but there is definitely a green in there. So red is definitely the most likely because the spinner's on it. True or false? No, that's false. What's the probability of blue ones? 2 that I want are blue. I'll write in blue here. 2 out of them are blue out of how many of them are there? How many little wedges are there?
5.
1, 2, 3, 4, 5 kinds. 2 out of 5. That's chances of blue. Well, they don't even ask that. Landing on green? 1 out of 5. Landing on red? 1 out of 5. Landing on yellow? 1 out of 5. Not landing on red. Ooh, weird. Not always means you subtract it from 1. Not landing on red. Well, this is landing on red. 1 minus that. So it's 4 out of 5. Another way to say it is, let's say there was a 20% chance of rain today. Then there's an 80% chance of not rain. You subtract it from 100%. If you were to select one shape at random, what's the probability of selecting a circle? Well, how many, what I want is the circles, so count them up. Over what's possible, well, that I can just go 1, 2, 3, 4, 5, and then there's 1, 2, 3, 4, 5. There's 25 that are possible, but what I want, somebody must have counted them by now. I think it's 8. I think you're right. 8 out of 25 then. 8 circles out of 25 things possible. Remember, it's always what you want over what's possible. This is experimental probability. That's where when we were rolling the dice, did you expect the 8 to almost never come up? No, but that was the experiment. And so it was what happened in the real world. That only 1 out of our 30 rolls was an 8. What was supposed to happen is 5 out of 36. That's because there's 5 ways to make an 8 out of 36 things that can happen when we do 2 dice. So my point, what you expect and what actually happens in the experiment are 2 different things. So say I flip a coin a gajillion times. If I flip a coin a gajillion times and I get 50 heads and 50 tails, do you get that not super surprising, but it was pretty likely to have been off a little bit, and let's say it would have been 51 and 49. What would you expect it to be? 50 and 50. That's called the theoretical. When it actually comes up different like this in the real world, that's called experimental probability. So to do the experimental probability, you actually do an experiment. The theoretical, if I flip it a coin, there's a 1 in 2 chance I get what I want. That's not 1 in 2. That's like 51 out of 100. This is experimental. This is theoretical. So experimental is the numbers that happen in the experiment. And theoretical is what should have happened. Okay. Sample space is all the things that could happen. All of the things. All of the things that could happen. You have to list all the things that could happen. It's a pain in the butt, so we almost never ask the sample space. Because you'd have to actually list, well, I could get this pair of socks, this pair of shoes, and that pair of boots. Or I could get this pair of socks, and this pair of shoes, and this pair of boots, and you'd have to list them all. It'd be a nightmare on this problem. So it's all the things that could happen. Let's just generally answer. All the things possible. What's the probability you end up picking up a pair of boots? Well, if you're just grabbing something randomly, there was how many that I want? 2 pairs of boots. 2 out of how many were possible? 12. See how I got it? I did what I want over what's possible. I wanted the boots, so there's 2 boots. Possible, 12 things. 2 out of 12. Should you reduce? Yes. But I've just talked to a fellow teacher who said on the AP test, they don't mark you down for not reducing. So maybe I shouldn't mark you down for not reducing. I don't know. I always want kids to reduce, but probably get credit for that. All right. What could you pick? The sample space? This is the list of everything you could pick. Do you seriously want to list everything you could pick? It'd drive you insane. What's the probability you pick a pair of white socks? Okay, everybody. I just did the last one. You do this one. What's the probability you're going to get white socks? Some kid that doesn't understand probability is going to go 5 because it says 5 white socks. That's not a probability. Rena, what do you think it is? 5 out of? You're just adding 7 and 5 and 2 in your head really quick, aren't you? 14. That's right. 5 out of 14. Or means add. Oh, wait. Or. There's the or. Sorry. Or means add. So then the white socks is 5. Or the fun print socks. 2. Or means add. This or that. Or means add. You get out a 7 out of 14, huh? These are the things I want. Is the 5 pairs of white socks. Or means add the 2 pairs of fun print. Okay. So, dang, this is a good question, but I want to get into the Schoology quiz. So, I want to go to the Schoology quiz now. Everybody open up the Schoology quiz. I'm going to do the first couple problems with you. Problem 1 of the Schoology quiz. Victoria, would you read it to me, please?
You create a new island in Animal Crossing, and you find that your island has one native fruit. The possible native fruits are pears, cherries, oranges, and apples and peaches. What is the probability that your island has a red fruit?
All right. There's pears, cherries, what else?
Oranges, apples, and peaches.
Okay. I need you to read that to me one more time.
You create a new island in Animal Crossing, and you find that your island has one native fruit. The possible native fruits are pears, cherries, oranges, apples, and peaches. What is the probability that your island has a red fruit?
So what I really want is red. I'd always come back to what do I want over what's possible. What's possible is 1, 2, 3, 4, 5 things are possible. What I want is red ones. Would you agree that cherries are red? Or apples are another thing that would make me win? I think those are the only 2 that are red, right? This or this. Or means add them up. There's 2 of them. 2 out of 5. That's it. Now, if it asks you for the decimal, then you'd have to divide them, which would be 0.4. 40% chance. Does it say you have to use decimal, or does it say you can use fraction? Does it say anything? It really should. It should give you a hint on whether or not I'll take a decimal or a fraction. Why don't you go on to the next problem, and I will go look in the key and see if they'll take either one. Okay, I have one last thing to tell you, to teach you, because they're going to ask you about license plates. So pay attention. I'll teach you the license plate kind, because there's 2 questions at the end. Some of them it's really short, but it's got 2 questions at the end about license plates. Remember I said you multiply choices? Remember me saying that? All right, so on a Minnesota license plate, you have 3 numbers and 3 letters. Number, like FEZ470. That used to be my license plate on one of my cars. It was a fun one. The Fez 470 is what I would call it. So anyway, it had 3 letters, 3 numbers. What's the probability that they would have picked an F? How many letters are there? Yeah. Okay, so you got to think of the probability of each thing. The probability of an F would be 1 in 26. The probability of an E would be 1 in 26, etc. But I said you should multiply choices. So how many choices are there for this first letter? 26 choices. Times how many choices for the second letter? 26, unless they don't allow repeats, in which case it would have been a 25, and I don't think we'll get there for a few days, but if we didn't allow letters to repeat, they do. In the real world, you can have like Q, Q, Q as one of your as your license plate. It could be all Qs. So 26 times 26 times 26. And then a really classic mistake here is kids think it's 9 times 9 times 9 because the numbers are 1 to 9. Actually, the numbers are 0 to 9. So how many choices are there for numbers? 10. So when you get to the license plate questions, that's how you do it. Could they make it more complicated? Sure. What if they said, we're only using even numbers? well, then it's not 10 choices anymore. You know what I mean? Or what if they said you can't use the letter F because it might spell a naughty word? So then, okay, well, then there isn't 26 choices. There's only 25. You know what I'm saying? But it boils down to choices, and you multiply your choices. All right, that's all I got for you for the video for today. Your homework is that short little Schoology quiz. If you get stuck, ask the kid next to you what they think, or ask me.